We begin our climb up the ladder of structure by noting that there are two kinds of quarks that are found in normal matter. Physicists call them flavors of quarks. These quarks are the up quark and the down quark. A proton is formed from two up quarks and one down quark, while its slightly heavier cousin, the neutron, is formed from two down quarks and one up quark. The red, green, and blue colors of the quarks represent a property that attracts them to one another. It is this color charge property of the quarks that hold them together in a proton or a neutron. These protons and neutrons can then combine to form the nucleus of each element in the periodic table. One proton in the nucleus makes hydrogen. Two form helium. Six, carbon. 8, oxygen. 79 is gold. And 92, uranium. Neutrons help hold the protons together. Because of their electric charge, protons would repel each other more strongly if neutrons were not present, and the heavier elements would come apart. There are approximately as many neutrons in each element as there are protons. Atoms are formed when the positively charged protons in the nucleus capture the negative electrons. Neutral atoms capture one negative electron for each positive proton in the nucleus. So, hydrogen has one electron to go with its one proton. Helium, 2 electrons. Carbon has 6. Oxygen, 8. Gold has 79. And uranium, 92. There are nearly 90 stable elements. The largest of them contain close to 800 fundamental particles joined in a complex but stable structure. But electrons cannot just gather around in a crowd. The strange, wonderful world of the tiny has some quantum idiosyncrasies. Electrons arrange themselves in shells inside an atom like the layers of an onion. And only 2 electrons can fit per layer. So the more electrons an atom has, the further away from the nucleus the outer shells must be. And that means these electrons are more loosely held. It is this difference in how tightly electrons are held in each different kind of atom that determines the chemical properties of the element. This accounts for the ability of metals to conduct electricity, the aloofness of noble gases, and the formation of molecules. It turns out that protons in 2 or more different nuclei can sometimes capture and fight over the same electron. And when that happens, atoms of different elements are joined together to form molecules. This oxygen atom is sharing 2 of its electrons with 2 hydrogen atoms. This is how a water molecule is formed.